Let's start. First, let's talk about the lattice energy. Lattice energy is the enthalpy change when 1 mole of an ionic compound is formed from its gaseous ions under standard conditions. For example, when gaseous sodium ion combines with gaseous chlorine ion, it forms 1 mole of ionic compound NaCl. Here, the lattice energy is negative value. And you have to remember that the lattice energy is always negative. In other words, it is always exothermic. This is because lattice energy involves the bonding together of ions, not the separation of ions. When ions are separated, they need energy supply to overcome the forces of attraction between cation and anion. Therefore, separation of ions absorbs energy. However, when bonds are formed, energy is released. Next, let's talk about the factors that affect numerical magnitude of lattice energy. Ionic radius and ionic charge are the two factors. When ionic radius decreases, in other words, when the ions get smaller, ions have a high charge density. This increases the electrostatic forces of attraction in ionic lattice. Bonds between ions are really strong, forming a stable compound. Therefore, it releases a lot of energy. When ionic charge increases, ions have a high charge density. Again, electrostatic forces of attraction in ionic lattice increase, releasing a lot of energy when bonds are formed. Next, let's move on to electron affinity. The first electron affinity refers to enthalpy change when 1 mole of electrons is added to 1 mole of gaseous atoms to form 1 mole of gaseous 1- ions under standard conditions. For example, 1 mole of gaseous chlorine atom gains 1 mole of electron to form 1 mole of gaseous chlorine -1 ion. The second electron affinity is the enthalpy change when 1 mole of electrons is added to 1 mole of gaseous 1- ions to form 1 mole of gaseous 2- ions under standard conditions. For example, 1 mole of gaseous oxygen 1- ion gains 1 mole of electron to form 1 mole of gaseous oxygen 2- ion. Usually, the first electron affinity is exothermic. On the other hand, the second and the third electron affinity are always endothermic. This is because there must be an input of energy to overcome the repulsive forces between electron and negative ion. Really important cycle appears in this chapter. This is a Born-Haber cycle. Born-Haber cycle is a particular type of enthalpy cycle to calculate lattice energy. Lattice energy is equal to enthalpy change of formation minus the enthalpy changes involved in changing the elements from their standard states to their gaseous ions. Born-Haber cycle is usually represented as an energy level diagram. Ion polarization is a distortion of the electron cloud on an anion by a neighboring cation. Polarizing power of cation refers to the ability of a cation to attract electrons and distort an anion. Distortion is greatest when cation is small and highly charged, and anion is large and highly charged. Among these cations, Li plus causes greatest distortion as it is the smallest cation. Among these cations, Mg2 plus causes greatest distortion as its charge is the highest. Let's talk about enthalpy change of solution. Enthalpy change of solution is the energy absorbed or released when 1 mole of an ionic solid dissolves in sufficient water to form a very dilute solution. For example, MgCl2 magnesium chloride dissolves in sufficient water to form Mg2 plus and Cl minus ions. We can represent this in another equation, like this. The meaning of these two equations is the same. Also, you have to learn that enthalpy change of solution can be both endothermic or exothermic. Compound is soluble if enthalpy change of solution has a negative or small positive value. Enthalpy change of hydration is the enthalpy change when 1 mole of a specified gaseous ion dissolves in sufficient water to form a very dilute solution. For example, gaseous calcium 2 plus ion dissolves in sufficient water to form a very dilute solution of calcium 2 plus ions. The enthalpy change of hydration is always exothermic. This is because bonds are formed between the ions and water molecules, and these bonds are called ion dipole bonds. The enthalpy change of hydration is more exothermic for ions with same charge, but smaller ionic radii. Smaller ionic radii means that ion has a higher charge density. Having higher charge density means there is a greater attractive force between ion and water. So when bonds are formed between the ions and water molecules, it releases more energy. The enthalpy change of hydration is more exothermic for ions with same radii and larger charge. Larger charge means there is a greater charge density, so therefore there is a greater attractive force between ion and water, releasing a lot of energy. We can also calculate enthalpy changes in solution by constructing an enthalpy cycle and using Hess's law. For example, to find enthalpy change of hydration, we can add lattice energy and enthalpy change of solution together.